Hello and welcome to this small demo of this little program I made called nDWatcher. I created nDWatcher when I was 18 years old during my first year at university. Before creating nDWatcher, during my last years at high school, I had been toying around with creating a software 3D engine, not knowing at the time that 3D calculations are performed by hardware precisely due to the high computing load they involve. nDWatcher extends this idea by implementing an arbitrary dimension projection engine which allows for the two-dimensional, mathematically correct representation of objects of any dimension. I chose to code it in R because I thought it was an appropriate environment for a mainly mathematically based project. nDWatcher is only a toy. Apart from there being little applications for this kind of tool and the fact that performing these calculations on a high-level language is obscenely inefficient, it also has some coding issues which exacerbate this inefficiency. As you can see, I prepared some easy to reproduce demos for nDWatcher. Among these examples you can find a cube, a wireframe of a sphere, a wireframe of a surface in a three-dimensional space, and a hypercube rotating over a four-dimensional vector which is second to the 3 plane where we are visualizing it, thus giving us that effect of having two pieces moving relatively to each other. The core concept of nDWatcher is that of perspective projection. A perspective projection is a projection which simulates how the human eye perceives images. Consider a three-dimensional object which we want to see from a specific point in space. We simply project that object into a two-dimensional plane between the object and us. This allows us to obtain a two-dimensional representation of the object. How does this work for higher dimension objects? Well, we can simply iterate the projection on successively lower dimension hyperplanes. Imagine we wanted to project a three-dimensional object onto a one-dimensional line. We could just project it into a two-dimensional plane and then project that projection onto a one-dimensional line inside the plane. Extrapolating this idea, we could represent objects of any dimension in a regular plane. Objects in nDWatcher are represented by vertices and segments joining those vertices. This is usually called a wireframe. To perform a projection of an object, we project each of the points and join them in the projection. This is possible because straight lines are preserved through projection. nDWatcher offers functions for projecting a single point, a whole object, projecting an object iteratively into 2 dimensions, rotating and resizing objects, and of course drawing a 2D object on the screen. nRotate and Draw allows us to rotate an object iteratively, projecting it into a 2D image and drawing it, giving us some kind of slideshow of how that object rotates. Apart from the object being drawn, nRotate and Draw takes the point along which to rotate, 2 vectors indicating the rotation direction and the angle of each rotation to determine the rotation. Then it takes a list of normal vectors to the hyperplanes on which to iteratively project the object each time, and finally it takes a list of distances of the projection plane and the reference point or camera from the object. Manually specifying objects such as a sphere through a wireframe can be too difficult. In that regard, Obtain Wireframe allows us to obtain a wireframe from a given parameterized hypersurface by instantiating it in regular intervals.